What does my slope mean? What does this mean? Yeah, so it means how many dolls it increases by per dollar. So the supply increases by 95 dolls for each dollar. Okay, now I have my slope. Mm-hmm. What's that? So we're trying to find our equation. So we just used our x and y values to find our slope, like we normally do, yeah? And these are the table, this is the table from 47, page 47.
Oh, from yesterday.
Mm-hmm.
All right.
Okay, we have our slope. You guys okay?
Yes, sir.
We have our slope. What other piece of information do we need to write our equation? The b. So right now I have y equals 95x plus b. How do I find b?
Look at the starting point. So you can
Yeah, I need to find my y-intercept. So it's where I start. But how can I use the points in the table?
You can go back to 0 and figure it out.
I could go back to 0 and figure it out. I can also plug in my x and y. So I have y equals 35 equals 95 times 1 plus b. So to solve for b, so I have negative 60 equals b. Can we have negative 60 for our y-intercept? No. Okay, what does our y-intercept mean? It's my starting value. How much money per doll would we have for our y-intercept?
That total?
The total.
Wait, what did you say?
Okay, so what's our x-axis? It's price. What does our x equal for our y-intercept? 0. So our x is 0 for our y-intercept. So our y-intercept is going to be the number of dolls supplied when the doll costs $0. So what negative 60 means is that when dolls are $0, there are negative 60 dolls supplied. So if I were selling a doll for $0, does that seem like a good deal for me? No, I don't want to sell anything for $0. I don't make any money. So that means that my interest in having dolls, my supply, is going to be really low because I don't want to do that. That doesn't benefit me. So our equation for supply, we found our slope is 95 and our y-intercept is negative 60. That's our equation for supply. So we can have negative 60 as our y-intercept, but it wouldn't necessarily have real-world context. Yeah. Oh, wait. What questions do we have about how we found this equation? We used our table from page 47. We used those x and y values. We found the slope with 2 points. And then we plugged in another point to find our y-intercept. Okay. Now, in partners or groups of 3 around you, you're going to work on the next 2 problems. So, part B asks you to find an equation for the demand. So that's the other line on the first page. And part C asks you to find the exact point of equilibrium. So we looked at the graph to find an equilibrium on Wednesday. Now you're going to find it exactly. Okay, and we're going to work on that for about 5 minutes. So we're going to use 2 of the points from the demand line to write an equation for price. So we've got the same thing. We have price is our x values, and our number of dolls demanded is our y values. So if we looked back at our table, we had $1, $2, and $4. Those were the same. Then our number of dolls demanded were 530, 400, and 140. What did we do first? What did you do first? Y2 minus Y1 over X2 minus X1. Okay, so we had 2 points, and Fabija says 400 minus 140. Oh, 530, okay. So we did 530 over
2 minus 1, which is negative 130 over 1.
Okay, so we get negative 130 over 1. Can we have a negative slope?
No. Yeah.
Yeah.
Yes, you can have negative slope. It just means that the amount, the price goes up, the amount of the demand goes down.
Yeah, so our demand goes down by 130 for each dollar. And then we know our slope is negative 130, and we're looking for B. So we just plugged in 530 for Y and 1 for X. And we add 130 on both sides. What do we get for our B? 660 for our B. So what does that mean?
When dolls are $0, the demand is 660.
Exactly. When dolls are $0, 660. So our demand equation is Y equals negative 130X plus 660. Okay, and then part B had us solving the system of supply and demand equations. So we had 2 equations that looked like this. How do we solve a system of equations? What are our methods?
Elimination and graph.
Yeah. And so on Wednesday, we solved it by graphing, and we got approximate numbers. And then today, we had equations. So what method would we want to use here?
Substitution.
Substitution. How do we know? Yeah, so they're lined up. So we have y equals on each side. And what did we end up getting for our equilibrium? What did we get for equilibrium? Yeah, what was our point? So we got at $3.20, $244 are both supplied and demanded. Okay. So the next problem we're going to look at is not in your book. The next problem we're going to look at is not in your book. So I think there's a blank page at the very back of your book if you want to use that. But just find an open space. So this is a problem that's similar to what we've been looking at, but it's got a few more tricks to it. So it says NSBE is holding a fundraiser, and they're selling roses for Valentine's Day. And Jackson is helping Miss Calhoun by taking money, just the very back for a blank page. It's not in our book. So Jackson's helping Miss Calhoun by taking money while Miss Calhoun takes care of the flowers. But then they're done, and Jackson looks down on the ground and he finds a $5 bill. And he wants to know, does this $5 bill need to be put back into the cash box? Or is this $5 bill just random? It's someone else's entirely. But Miss Calhoun doesn't know. So they were selling each rose for $5, and they were selling.
So they need to see how many roses they sell to see if it belongs to a rose or not.
So they will need to do that. So let me keep going for a second. They sell each rose for $5, and each bouquet of 6 roses for $20. Miss Calhoun says she sold 75 roses, and they have $285 in the cash box. Do we have any totals in this problem?
285.
285 is a total, and 75 roses is a total. So, won't be y, but it will be set equal to it. So I know I have 2 equations I need to write. One is going to be the number of roses, 75 roses, and the other is money. So what variables can I use? Yeah, so I'm going to use S for single roses. That's when I just sell them individually. And I'm going to use B for a bouquet, which is 6 roses. So it's 6B? What'd you say? Yeah, okay, so Sean, walk me through. What's our first equation? So we have something equals 75. That's going to be our number of roses. And you said we're going to need 6B, right? Plus 20. So we're looking for number of roses that we sold. So 6B is our bouquets. That's how many? 6 times a bouquet. That's 6 roses per bouquet. What else do I add to find all the roses?
The $20, the 6 roses. Oh, the 5 for each bouquet.
So we know that the bouquets have 6 roses.
Oh, they have $5 for each of them.
So we're adding how many single roses and how many bouquets. That's the 6B. We have 6 roses per bouquet.
Okay.
So S means single roses. And bouquet is 6 roses.
Wait, so how is that?
So let's look how we would do money. How much do the single roses cost?
$5.
So how would I write that?
5
How many? Yeah,
I
plus.
mean 75. I mean, oh, 20, yeah, okay. I'm so confused.
So the rest of this problem. Okay. Hold on, we have 1 minute and I want to make this really clear. We would solve this system, and if it made sense, we would know that that $5
Fit with the, fit in the box, or didn't fit in the box.
exactly. Okay, we have a homework. We have a homework on Canvas that is due on Monday, and it's all about writing our systems of equations.